Recording, solving an exponential equation by using logarithms, decimal answers, basic. All right, for this problem, guys, I'm going to give you two solutions. The one that Alex proposed, and another one that I'm going to propose. So the first one is Alex. And the other one is the additional, no, the another way to solve this. All right. So we have 7 elevated to the y minus 4 exponent, and that equals 2. We want to find the value of y that makes this equation true. And what we're going to do first, as Alex suggests, is okay, we're going to have to use the calculator eventually. So we want to have logarithm base 10 or natural logarithm as the base of our logarithms. So I'm going to put logarithm base 10 of 7 to the y minus 4 and logarithm base 10 of 2 in the right hand side of the equation. Remember that this is a valid thing to do as long as we do it in both sides of the equation, in both of them. If we just do these kind of things in one side of the equation, then everything is going to be wrong. So far so good. Right. Now, this is going to be helpful because I can use now the properties of logarithms and take this exponent out of the logarithm in the left. That will be, remember, put it in parentheses, y minus 4 times the logarithm base 7, but logarithm base 10 of 7, and that equals logarithm base 10 of 2. All right. Now, be careful with these parentheses, because if you don't use parentheses, then it will look like minus 4 is multiplying the logarithm of 7, but not the y, but both are being multiplied by it. So be careful. Now, we can start manipulating this. The only thing we want is the y variable. So y minus 4, I'm going to divide both sides by logarithm of 7, and it will look like this. And then I'm just going to add 4 in both sides of the equation, and it would look like this. And that is going to be my answer. I can put this right away. I can put that in the calculator. Is going to be a division, logarithm base 10 of 2 divided by logarithm base 10 of 7, and then I'm going to add 4 to all of that. I'm going to press what is that equal to. I have to round up to the nearest 100. That means it's going up. So 4 point, I'm going to put approximately 4.36. I'm going to leave it as that and see what happens with the other option that I want to give you, because this is another interesting option. We have at the beginning a logarithm. I'm sorry, the 7 elevated to the y minus 4 exponent equals 2, and we can use the definition of logarithms and exponentials. This means, in a logarithmic way, that logarithm base 7 of 2 equals y minus 4, right? Okay, so this is something we have been practicing, and then we can apply in here the change of base. We also practice in another exercise in this week. I can write this guy in here differently, doing a change of base. I want the new logarithm to have base 10 in order to put it in the calculator. So logarithm base 10 of the number that is inside the logarithm divided by logarithm base 10 of the base will be the same thing. So that's what I did with the change of base. And then the only thing I have to do is adding 4 in both sides of the equation, and you will see, and you already have already seen that I have exactly the same thing in the two options. So this is going to be also equal or approximately equal to 4.36. I'm going to write that down here, 4.36. You can apply whatever you like the most. Both are good. My option, I think, is good because you're going to be practicing the change of base. Okay, press check.